I'm Doug Sillars. I'm originally from Seattle, and as the great introduction said, I'm traveling traveling with the family around Europe as a digital nomad. This photo is taken in rural Ireland, and so I'm going to talk about how to deliver images in a way that are super fast when you're in a big city that has 4G, but also when you're surrounded by sheep in the middle of nowhere in Ireland. Because it's important that our content works everywhere, not just in the big cities with our phones that we have here, not just everybody's phones. So I'm doing freelance developer relations, so I talk to developers about how to do performance, whether it's native or web, mobile or desktop. I do workshops on performance, images and video. I wrote a book on how to speed up your Android app, and if you're interested, that's the PDF, so feel free to download it. I'll post the slides up later too, so you can get a hold of all the URLs. If you ever want to get in touch with me and talk about performance, I'm always open to do that. I'm the only Doug Sillars on the internet, so it's pretty easy to find me. But before we start talking about performance and images, I want you to think about this walkway that's nailed to the side of an Alp. And how many of you sort of get this nervous feeling when you think about walking across this walkway that's nailed to the side of a mountain? Anybody? I see some hands, I see some nods. Yeah, it's pretty terrifying. I walked across this about 2 years ago, and my daughter, who was 6 at the time, decided to jump the whole way, adding a sort of rattling effect, which was really kind of interesting. But 2 years ago, Ericsson did a study, and they put sensors on people's heads to measure stress responses to different actions. And they found that queuing up for a line raised your stresses a little, raised your stress response a little bit. They found that thinking about standing on the edge of a cliff, like you all did a moment ago, made you feel stressful. But interestingly, they found that a slow mobile experience is actually more stressful than standing on the edge of a cliff. So when you build something for mobile and it's slow, your customers get the feeling that you were just having about 90 seconds ago. And if your customers are feeling awkward and unhappy when they're at your site, how likely are they to come back? How likely are they to buy something? So we really want to think about that, right? We want our experiences to be fast. Google found that a 3-second delay leads to 53% abandonment of a mobile website. Another study found that half a second frustrates people more, lowers their engagement. Amazon and Walmart found that people spend less money, right? And then finally, my favorite stat is 4% of mobile users admit to throwing their phones when there's a slow mobile experience. So when you're on a bus and you see someone with a broken phone, hopefully that's not from your app or your website. So what can we do to speed up the content that shows up on our website or on our app? If we look at this is the average website from the HTTP archive. And if you look, it's 50% images and it's 25% video. So if we can optimize the content, the images and video that are downloaded, we're really going to speed up what shows up on the screen. If we can make them smaller, they download faster. Most sites don't have video, but this is the average effect. So like if Jeff Bezos came and sat over here in the corner, we'd all make $50 million a year on average. So when you have a video on your site or in your app, it really changes the amount of data that's being downloaded. So what can we do? Is anyone here familiar with Lighthouse? I see a bunch of hands. It's in Chrome DevTools. It's in Web Page Test. It's a Google tool that does audits on your web page to look for ways to speed up your application. And inside Lighthouse, there's 4 optimizations. There's quality, there's format, sizing, and lazy loading. And you get scored from 0 to 100, where 0 is bad and 100 is good. Now, what's really cool is web page test users. Anyone? All right, I see a couple hands. If you build websites and you build mobile websites, web page test is a great way to audit how fast and the performance of the web page that you're building. And there are instances all around the world, so you can test your web page in the States, in Europe, in Asia, so you can really get an idea of how your web page performs around the world. So Lighthouse is built into web page tests too, so you get those audits automatically when you use web page test. And then there's another open source project called the HTTP archive. And that actually, what that does is on mobile and desktop, it tests 500,000 websites every 2 weeks. And then throws all that data into BigQuery. And so you can look at it. It's all with just SQL commands. What's going on the internet today? What are people doing? What are the trends over time? Because it's every 2 weeks. I did this study when they were doing 500,000 sites every 2 weeks. They're now up to like 1.2 million sites every 2 weeks. So you can get a whole lot of data if you're interested in that. So what I did is I went into the HTTP archive and I looked at these optimizations. What are people doing? Let's start with image quality. Lighthouse recommends that you save all your images at 85% quality. When you save something at 85% quality, you're losing some of the pixels, right? You're going to lower the resolution of the image. In general, 85% is good enough. No one will notice the difference. If you save it at 85%, no one will know the difference. You've saved some data. You can use a tool like ImageMagick to optimize it. Cloudinary is a cloud-based tool where you upload the full-size image and you just put a parameter in the URL and it creates the quality 85% image for you. So this is in Riga, Latvia. I took this picture a couple months ago, 3.6 megabytes. 85%, it's half the size and you can't tell the difference. Seems like a pretty straightforward and simple optimization to do. So if we look at what's out there for 500,000 websites, 43% are doing it right, but a full third of the internet is completely not optimizing at 85%. They score a 0, which means none of the images were at 85%. If we look at that 33% of the internet that's failing, Lighthouse gives you an idea of how much faster it would be. And so I took all of those and I found the median, right, the 50th percentile. And on 3G, it would be, that website would be 2.8 seconds faster and use 420 kilobytes less data. So that's a pretty big improvement just by making your images just, 85%. Pretty straightforward. But what if we could do better? What if we could get smaller than 85%? And some images you don't want to, and you'll start noticing. But some images you can, like this one at 50%. If you start looking, there's some kerning around that. There's a lot of fancy stuff going on here. When I take it down to 20%, it's really obvious this image is really low quality. And you wouldn't want to put that up on your website. You can see all the banding in the sky. So we know if we start graphing all the data, we know that 85% is good enough according to Google. We know that 20% is bad, but where's the sweet spot in the middle? And luckily, there are algorithms that'll do this for us. Google has Buter-Augli. The compression folks at Google are all in Switzerland, and they name all of their compression algorithms after pastries. They just do. We'll see more of that, I think, later in the talk. The other one you can use is structural similarity. These are tools that are available online. This is an open source tool. I optimize the image. You can use a tool like Cloudinary, just set it to auto, and it finds that sweet spot in the middle using structural similarity. There's the image. You can see I saved another, I guess, about 400 kilobytes. So that's going to download that much faster because it's 400 kilobytes smaller. We can run it through web page test. And so with web page test, I just enter my URL. I'm actually testing in Virginia because they have real Android and iOS devices there. It's not emulated. These are actual devices. I run the test, and you can see my load time for the full image is 20. And you can set the speed of the network. So I set these at 3G, 21 seconds down to 9 seconds. So that's a pretty big improvement for just one image. And then, of course, if you do this to all your images, you're just going to drastically speed up your web page. The next thing I want to talk about is format. There are a lot of different image formats out there. Here are the average sizes of all the formats. As you might imagine, the most popular format out there is JPEG. I saw a tweet late last month that JPEG just turned 26 years old. So, I mean, JPEG's been around a while, right? It's super popular. It also tends to be the largest file, and that's probably just because there's so many JPEGs out there. But let's talk about vector graphics really quickly, because vector graphics are a great way to reduce the size of the images that you have on your web page or in your app. And so these are SVGs, but they're vector graphics in Android, right? You can do all these different things, and they're drawn as shapes. They're vectors, and so they're just XML. And so they look great no matter what size you stretch that Twitter icon. If you see some pixelization here, it's because PowerPoint doesn't take SVGs, so I had to paste in JPEG screenshots of my images. Can be complicated sometimes. All right, but let's take, for example, the Facebook logo. I snagged this off of a website in Brazil. And I was like, let's check out what this SVG looks like. And it looks something like this. I've zoomed in at the bottom here so that you can see there's something really strange here with Adobe Illustrator. And if you look up here at the scroll bar, you might get a hint about something bad is about to happen. In fact, there was 1.3 megabytes of Adobe Illustrator cruft added to the bottom of this SVG file. So I opened up the XML, highlighted all of the Illustrator stuff, and I made it 900 bytes. So I removed like 99 point, I don't know how many nines. I need to do the math. It's probably at least 4 nines of data to make it 900 bytes. Of course, then you can gzip it, and it's smaller or broadly bread, Swiss bread, Google compression algorithm. You get down to 440 bytes. So when you do SVGs, they get really, really small if you do them right. I guess the moral of this story is you should probably test it before you roll it out to production. They had 5 SVGs that were like 5 megabytes worth of data on their web page. It should have been 2K. But I want to talk a little bit about WebP as well. WebP is about 6, 7 years old. It's another Google format. And you're saying, well, Doug, it's a Google format. And if you looked a couple weeks ago, you would say, yes, indeed, it is a Google format. It's Chrome and it's Android. So, you know, the support hasn't maybe taken off quite as much as you might want because, you know, it's just Google. Because it's a newer algorithm, it has a lot better compression. The images are generally a lot smaller. If you look at the notes from a couple of weeks ago, you can see that Safari and Firefox are thinking about it, and it's in development for Edge. And rather than update that slide, I wanted to put this tweet up from earlier this month. It's now live in Edge. So we've got 2 major browsers, and Firefox is working on it. Like they're actually, you can watch the bug in, you know, you can watch it updating as they're making fixes on it. So by the end of the year, it's going to be, maybe beginning of next year, it will be in Firefox as well, which is super exciting. So what happens when I take that optimized image that I had earlier and I make it a WebP? Well, I just took it from 1.5 megabytes or 1.4 megabytes to under a megabyte by changing the format. So we can see here from structural similarity, it was 9.4 seconds, 1.5 megabytes, to 7 seconds, about a megabyte. So another 2.5 seconds just by optimizing the format. You know, here I've got it, so, you know, serve the WebP if the browser supports it, fall back to the JPEG, always have an alt tag, right? Simple stuff. Image format use, according to the HTTP archive and Lighthouse, 67% of the internet is not doing this. So there's a huge potential for speed improvement just by changing the format of the images on your website. If we look at the median website on 3G, 4.1 seconds faster and 600 kilobytes less data. So 4 seconds faster on 3G by changing the format of your images. So that's a pretty huge improvement that you could possibly do just by doing image format. Sizing. So we all know that when we take a picture with our phone, it's generally ginormous, right? This is an image I took. It's in Novi Sad in Serbia. It's 13 megapixel image, right? I do my optimizations. I go from 1.6 megabytes. I get it down to 800K. That's still great. But what happens when I serve that image to a tiny low-end phone, right? What ends up happening is I take my 13 megapixels, the phone downloads all 13 megapixels, and it displays 500,000 of them on the screen, meaning that the CPU has to fire up and throw away 95% of the data that it just downloaded, which, you think about it, is pretty wasteful. The closest analogy I can think to that in real life is when you buy something from Amazon, right? And you start going through all the paper, and then you realize that your kids ordered like a pack of 2 pencils, and it's in this ginormous box. We've all been there. But we don't want to do that when we're downloading, when we're sending stuff from our server that's costing our company money, right? Why would we send something big when we can send it smaller? And we don't want to waste our customers' data if they're on mobile. And honestly, on lower-end phones, you've got to fire up the CPU to throw away 95% of the data. So it's like a double taxation on these low-end phones. They have to download the huge file, and then they have to clean it up to put it on the screen. This is a little complicated. These are all of the Android devices that hit Akamai in one day in December of last year. So the size of the box is how many of each one. So these are all Samsungs. The color is how fast they are, so the Samsungs have really fast processors. But you can see out here at the Android event horizon that there are a lot of really low-end, slow devices with not a lot of market share. So how do we optimize the images for all of these different devices? Well, if you're a web developer, you know that the trick is responsive images. You generate a set of images. In this case, I've set them up so they're all 25 kilobytes different in size. So the idea with 25 kilobytes different in size, I'm not wasting thousands, millions and millions of pixels each time. I'm only wasting up to 25 kilobytes, right? The most excess data I could do would be 24.5 kilobytes or something. So I generated a whole bunch of them. I found the right size for my screen. And now instead of 12.5 million pixels, I'm just wasting 100,000. So it's a much better efficiency in my images. There are a lot of great tools that will generate lots of different breakpoints for you. This one sets them at 25 kilobytes apart each. It's open source. This is the web interface if you want to do it that way. So you can automate it or you can do it manually. There are a zillion different ways to do it. I wanted between 200 and 1,400, 25 kilobytes apart, and give me 20 of them. Get a list of images. The web page looks like something like this. So for 200 pixels, send this image. If it's up to 371, send this image. And rather than look at the code, let's just look at the website because that's cooler. So this is the web page, and what I've done is every other image is sepia. So I'm going to change the size of the screen, and it'll download a different image. Now, you wouldn't do this in real life. You just pick the one image and show it to your customer. But I want you to see how quickly it changes when it's a large image, how much 25 kilobytes makes a difference. First, I have to find that first breakpoint, because this is a huge screen. All right, there's the first one, right? 25 kilobytes is not a huge difference in size for these really large images. But you get all the way down to here. This is like a 25 kilobyte image for your really low end, 50 euro Android phone that you can get at the grocery store. I don't know, do they do that here? I know in the UK you just walk into a Tesco and you can buy a cell phone. It's kind of nuts. The quality is probably not what we're all used to carrying around in our pockets, as you might imagine, by buying a phone at the grocery store. So there's this new Android Go is kind of the same idea. They're running the latest version, but they only have 512 megabytes of memory. They have a very low-end processor. I was just in the UK, and I know they're about 60 or 70 pounds each. So they're brand new Android phones, but they don't have them plugged in, probably because they don't want people to see how slow they are. But what I did here is with Cloud and Area, I've set the width for each of these images. So it's generating these images for me on the fly. And then if you're really interested, it's doing the sepia on the fly too, right? Every other image is set as sepia, and it just generates that for me. It's a kind of a cool tool. It's fun to play with. So what happens when I do a responsive image on a Motorola G4? Well, now, instead of that full-size image that's 13 megapixels, it's downloading an image that's appropriate for a Motorola G4. Not a megabyte, but 121 kilobytes. So, of course, it's 5 seconds faster to download, right? If you take out 80% of the file, it's going to download way faster. If we look at what people are doing from the HTTP archive, most people are doing this. Over half, maybe not most, over half of people are passing at this, almost 60%. But a good 20% of the internet is not doing this. And if you're not doing responsive images on mobile on a 3G connection, the median site is 2.7 seconds faster and another 400 kilobytes in savings. So if you're not doing it, it makes sense to think about this because it'll really speed up the delivery of the images, which then speeds up your web page or your mobile app. Now, so far, I've talked about 3 different optimizations, and they're all per image basis, right? What you can do to optimize the images that are on the server. But what if you can't control the images on the server? What if you're building an app for a company and you can't do that? Or what if you just don't have access to do that? You could look at lazy loading. And so the idea behind lazy loading is, here's again my simple web page or my simple app. What if you only load the images that are on the screen? And then you just load those other ones when they come up on the screen. You've seen this on web pages, right? Medium does this. Facebook does it. I think Pinterest has started doing it. So when you scroll up, those images are downloaded. Now, if this web page loads, instead of 6 images, you're only loading 2 at startup. So the page is going to load significantly faster. If we look at the data, 60% of the internet is not doing this. Those folks that aren't doing it would be 3.5 seconds faster on 3G and another 500 kilobytes less data on load time. Now, if people scroll, obviously those will load up eventually. There was some interesting research on how many people actually do scroll on web pages and how many viewports you go down, and like 57% of people don't scroll past the first screen. 15% see the second screen, and it goes down to like almost nothing beyond that. So lazy loading is a great opportunity to save data. So here I am on my Android phone. I search for cats in costume, as one does. And this green placeholder image turns into a cat dressed up like a dinosaur. The pink one becomes a cat dressed up like a bunny rabbit. The orange one, pumpkin? I don't know. But as a customer, I know that images are coming. And then once they come, what's great is now the page is fully laid out, which is awesome because you don't have the reflow of the text or any of that annoying stuff that happens. And then when the image comes, you get the image on the screen. If you wanted to go fancy, instead of just color, you could generate an SVG representation of your image. So this is a waterfall, and you can see instead of just being green, it's kind of green and white. So that pops in first. It's 500 bytes compressed. This is 120K. It pops in a second later once the page is loaded. It's open source. There's the URL for the tool to do that. So we can do some experiments. This is a web page that I built. This is the desktop view shrunk down so we can see all the different viewports, and each viewport is marked by a red line. So that's what this is what people see when they load my web page on a desktop. And you can scroll down to all these other images. If I load this web page in Chrome, this is the way I see it load, right? I see the text, then some images start appearing. I'm using the placeholder images. And then some of the images are actually loaded, but they're way down here. And nobody can see those yet because they haven't started scrolling. They just think the page hasn't finished loading yet. And you can see the text continues to reflow out. All of these images are loaded, and if you look, this image here at the top of the screen still hasn't loaded yet. So the browser is loading everything, but it may not be in the order that we expect or the way we want it to, because we really want this stuff at the top of the screen to load first. And so this is really where lazy loading comes to save the day. It doesn't load these until you scroll to see them. Inside Canary today, there's an experimental flag that turns on lazy loading. So Google's actually experimenting on how to optimize the delivery of images on the web. And so I turn on that flag, and what you first notice is it lays out the whole page right away, right? There's no reflows. And so what it's doing is it's taking the first 2 kilobytes of every image, and in the first 2 kilobytes, it gets the dimension and the size. And so it can lay out the boxes where all the images are going to go. And if you could zoom in, there's a little bit of text there. It actually says the size of each of the images, so you can know what's coming and how big they are. But what you can see is all of the images at the top load really quickly, and then the images on the page sort of load in the way that your customers would scroll down the page. So this is kind of exciting because this sort of takes it away from us and puts it in the browser, of course, just for Chrome, but pretty exciting. The last time I looked, which is about 3 weeks ago, this is still slower than loading the page regularly. So there's still some optimization work. That's why it's behind a flag in Canary. But it's kind of exciting that people are experimenting with this on ways to optimize images and the delivery of the images. Animated GIFs. Anyone love animated GIFs? Love, hate? Love, hate. You're developers, right? This is my goat Nora back in the States. I took this video, it's 1.4 megabytes, and we need more goats and we need more GIFs, so I present this to you. It's great. GIFs are even older than JPEGs. They're from the 80s, and when you read about the animated format, it says, we have this animated format, but we don't really recommend that you use it. And one of the reasons is because an animated GIF is actually bigger than the movie itself. So it's now 270% bigger. It's looping. But this is actually a worse video because this is 256 colors, right? It was the 80s. I try to tell my kids that in the 80s they only had 256 colors, but they don't believe me. Why is it so much bigger? When you have a video, you can compress on the X and Y coordinates, but you can also compress through time. GIFs don't have the ability to compress through time. It's actually just a flip book of static GIF images. And so you can see here, I stripped out all of the different images. But what can we do to make it smaller? So I made it into a movie. I stripped out some of the thousands and thousands of colors that my phone collected. And I stripped out the audio channel because Gifs are silent. There's no reason to download the audio channel. I'll talk about that again in a minute. But now it's 250 kilobytes. So it's 93% smaller than the animated GIF. Throw that into a video tag if you're building for the web. You set it to loop, you set it to autoplay. For mobile, you have to set it to muted as well, and that's for the people in the back of the room who are playing around on their phone. That means the video won't play loudly when you're sitting at a conference, and you won't be embarrassed. And then you have to put plays in line for it to work on iOS. Now, the problem with putting it in a video tag if you're building a web page is that browsers are really smart, and video is always the last thing to load because they're ginormous, and they want to make sure the CSS and all that other stuff is, and the JavaScript and everything else is downloaded first. But the image tag is fast, and in Safari, you can do this. Safari will actually load a video from the picture tag. And so for your iOS customers and for the people who use Safari Desktop, this will actually work. It will load the looping goat video at 250 kilobytes. If you're on Chrome, you can do an animated WebP if you want. That's about 3 megabytes. And then everybody else gets 3.8 megabytes. And you start thinking, wow, that's a huge difference. And indeed it is. 22 seconds for the GIF on a 3G connection, 4.5 seconds for your iOS customers. I have to imagine this is going to show up in other browsers really soon because that's a really powerful way to speed up the delivery of this content. And so I've kind of gone into video a little bit. So let's talk really quickly about video, because video is a growing part of what's going on inside apps, what's going on inside web pages. And they're bigger than images, and so optimizing your video is probably even more crucial than optimizing the images that you have. And the data proves that. Basically, if your video is slow, people get angry. And we know that if people get angry, they chuck their phones. So we want to be really careful about making sure we serve video that's quality to our customers. And when you look at the top video metrics that people talk about, what are the most important things when you're delivering video? The 3 metrics are really easy. Did it play? You'd be surprised. Did the video stall? Because we know if a video stops playing, people leave. That's not playing. I'll come back to it later. They never come back. And did it look good? So let's talk about, does the video start? This is data from Q1 of this year. It's from Conviva, and they do analytics on video, like how to video playback, and they've aggregated all of this data, and they found that only 85% of videos actually played. Imagine if we were building an app and it only worked 85% of the time. Or we were building a web page and you got a 405 15% of the time, right? That would be really bad, but here we're seeing the same thing with video. 2% of the time it fails to start completely. 11% of the time the customer abandons the video after they press play, they wait, and nothing happens. They're like, they move on. That ends up actually being 2.4 billion plays in 1 quarter of this year. They've updated the stats for Q2, but it's the same data. Roughly the same numbers. 800 million hours of video playback were lost in the first 3 months of this year. So what's going on? Let's look at video that failed to start. I went through a bunch of data in the HTTP archive. I see a bunch of 404s. I see a few 500 errors, things, but it's way less than a percent, like 0.2%. So why is a video failing to start? It's probably stuff like this. And I have an Amazon account in America, and when I fire up Amazon Video, it says, oh, yeah, you're in France. Here are the videos you can't watch. Here are the ones you can watch. Or it says, here are the videos you can enjoy when you get home. It says it nicer. But I don't click on those links and then get a disappointing message like this. It tells me straight up, like, we have these videos. You can watch them when you get back to the States. I find that a lot more reassuring than 231 requests and 3.1 megabytes to say, oops. It looks like it took 19 seconds, but they actually have a heartbeat measuring the oops because they want to measure, they're doing analytics to measure the playback, and this one was an oops. I was really disappointed by this experience, and so, as you might imagine, your customers probably are as well. Let's also look at the video that was abandoned. Why do people give up? It should have worked. We did everything right, right? It works on my machine. Everybody, according to Akamai, everyone will wait. After you press play, everyone will wait for 2 seconds But then you lose 6% of your customers every additional second that the video doesn't play back. So if your customers are waiting more than 2 seconds, you're losing your audience. It depends on the type of video. So if it's a short video, people give up faster. So if you've got videos of a cat dressed up like a shark on a Roomba chasing a duck, after about 3 seconds, people are questioning their life choices, and they move on. But if you're showing a TV show or a movie, if you're going to wait a minute, if you're going to watch an hour-long show, you'll wait 30 seconds. That's not such a big deal. But you still want it to get there quickly. So this is a screenshot from a tool that I helped build when I was at AT&T, and is running network traces on a mobile device. And so these are all the packets coming in and out. This is the throughput, and this is time. And so right here, I said, hey, I want to watch a movie. This is it downloading the ad that I had to watch first. Yeah, we all hate that. And then nothing's really happening here for 30 seconds. This is actually analytics, and then this is the movie starting. And it's interesting, the analytics was sent over port 80, so I can see it. This one says, hey, they've watched 25% of the ad. Hey, they've watched 50% of the ad. Yeah, you can follow the metrics there. And then when the ad stops, the app is like, oh yeah, they want to watch a video. And it starts downloading the video. So guess what you get? You get about 10 seconds of spinner. So you have to you have to download the ad, you have to wait 30 seconds to watch the ad, and then you have to wait another 10 seconds. Do you think they're losing people on each step of this funnel through the process? Wouldn't it make more sense if you know they're sitting there for 30 seconds and you know the network isn't busy, download the movie while the ad is playing, right? Then when the ad is done, it's like, bam, you're right into your feature. That's exactly what customers want. So preload the video if it makes sense. If you know they're going to watch the video and you know the network's free, jam as much of that into the buffer as you can, and then it'll play back and it won't stall as often, and it'll start right away. However, in the browser, you can set your video to preload equals auto, whether or not you think that people are going to watch the movie. So this is a waterfall chart from Web Page Test. This is all the CSS and images and JavaScript. But they set the video to preload equals auto. So at the end of the load of this web page, it downloads 23 megabytes of video, whether or not you press play. So how many times are you on your phone and you're like, oh, there's a video, but I don't really care that much. I don't want to download that on my phone. I don't want to waste the time. The developer of this website decided for you. Now, if you are the developer of this website, think about every single time somebody hits your homepage, 25 megabytes of data is coming out of your server. Like, there's a cost associated with all of this as well. So if you think people are going to watch it, it makes sense. But if only like 5% of people are going to watch the video, don't download 24 megabytes of video to everybody's phone or desktop or anywhere. It's just kind of wasteful. There's another tag. There's preload equals metadata. It does like 2 or 3% of the movie, and that's default in Chrome. It sort of makes sense. I've seen issues where people have like 250 megabyte videos and still ends up being a huge bit of data. Don't put huge videos like that on mobile devices. And then there's also preload equals none. So it takes a little longer for the video to come, but you're not doing this to every single person who visits your web page. Background video, huge. Everybody loves background videos. There's studies showing that 80% engagement rate by adding a background video to your web page. So there are a lot of people pushing to add background videos to your web page. This is great, right? Boy, I really want to take my kids there. Those kids are having so much fun. That video was 5.3 megabytes. And the problem with that is I mentioned this earlier, it has an audio track associated with it that nobody hears. If a video plays and it has no audio playback, does it really have sound? Or there's some, right, a tree falls in the woods sort of thing going on here. But you could make that image, that video 5% smaller just by like cutting out the audio track, which is pretty easy. So if the video's silent, just strip out the audio track and you're going to make your everything faster. So if you're doing the GIF trick that I showed you earlier, just strip out the audio track. There's no need to have it. No one's ever going to listen to it. The next trick is if you're serving that same video to mobile, and you can see here in the web page test, the green is the video. It's being downloaded. But if you look at their CSS, they do a display none if the screen is smaller than 600 pixels wide, which means that I didn't see it. So if the viewport isn't going to support the video, don't download it. Save the data out of your server and to your customers. One more video background. This is a web page that if you sit there for like a minute and a half, you might see the background video. But who sits at the top of a page like this for a minute and a half waiting for the background video? Why does it take so long for this video to load? First thing we learn from this video is Bob Ross is not just a painter. No Bob Ross fans here? Oh, man. That one gets big jokes in the UK, or big laughs in the UK. All right. This video is 33 megabytes. Why is it so big? It's 27 seconds long. It's 2,500 by 1,200. It's a ginormous video. This is bigger than most desktop screens, much less mobile screens, and it's being streamed at 10 megabits per second. If you go to the web page, you view the source, you put it in your browser, it stalls just playing it in the browser without everything else. So my best practice here is resize your video so that it's a reasonable size for mobile or desktop, in this case, desktop devices. A special trick is if you rename the file to 720p, that doesn't actually re-encode the video. It is new. If you did resize it, if you made it 720p, it would be 4.3 megabytes. If you did 1080p or 8.1, it's big, but it's going to download, right? 30 megabytes just isn't going to download. They try to download that on mobile too, but Chrome gives up after about 8, 10 megabytes, depending on the speed of your connection. That's still wasted data for both the host and for you. Okay. Third parties. How many people just like, you know, you've seen in YouTube or in TED Talks, there's a share button, right? Everyone love TED Talks? Yeah, some hands, all right. You hit the share button, you get a one-line div, like, I'm going to paste one line of code into my web page. That couldn't be bad, right? All right, I built a web page with that one-line div in it, and 118 requests, 32 megabytes of data. So it auto-streams the entire video, whether or not you press play or not. So if you know people are going to watch the video, that's great, but if it's down in a carousel at the bottom of the page and you embed that TED Talk, know that it may be downloading a whole bunch of data. So for any third party, this goes beyond video, this goes beyond images. You should audit to see what they're doing, right? You add something, see what the difference is without it and with it, to see what the performance impacts of adding that might be. You know, you're thinking, oh, it's just one line, how bad could it be? It could be 118 requests, 32 megabytes bad. So when you do video streaming, this is actually a video stream, so you can see it's downloading all these different segments of video. They're usually about 2 to 4 segments different in size. And how does the player know what segments to download? Well, there's a thing called a manifest file that lists all the different bit rates that are available. The player chooses one of those streams. It starts getting a list of video segments. It downloads them. And ideally, you get something like this where the video plays right away. Because as we know, we want the video to play right away. Once the video starts playing, the player starts monitoring how fast the data is coming in and out of the network, and it can pick the optimal bit rate. And so here is, you know, another a manifest file. Those are all the video tracks. Those are the video tracks in iframes. These are all of the audio track and all of the subtitles. So it's a file that lists where all this information is, if you're interested. Let's just look at the video tracks. And so what you get is you know, this is the audio track to use. There's the bandwidth of this track. Here's the codec, the resolution. And then here's the place where you find all of the segments to download. And so in this case, in HLS video streaming, the player always picks the first one. It has to start somewhere. It doesn't really know what the network speed is, so it's going to download this 1.4 megabits per second. So if this is too high for the network you're on, say you're out in the middle of nowhere and you're trying to watch a TED Talk, the buffer might take a long time to fill up here, and the video might not play back really quickly. So the player knows he's going to abandon if it takes too long. So it changes the bit rate to a lower bit rate. The buffer starts filling up, and then the video plays. But we added a step here, right? We tried to download something, it failed, and then we fell back to something else, and the video started playing. Now we're getting into why people are abandoning video, right? If we add a couple seconds, and the average video start time in Europe is 4.3 seconds, we're on the low end of that. We're slowing down the delivery of our content. So what a lot of video providers do is they start with the lowest quality bit rate. And you've seen this. You start a video and it's all pixely for the first couple seconds, but it started up really fast. It's because there's a really low bit rate. It comes through on your device really, really quickly. Then after a couple seconds, it finds the optimal bit rate for your network connection. It sharpens up and it looks great. You see someone do it the opposite way. It starts with this really high bit rate. It doesn't play. Right? We added a step to this ideal, the ideal pathway. Adding that step can add many, many seconds to the delivery of your content. Now, Amazon does something completely different, and some other providers do something completely different. I call it the Goldilocks approach. Not too small, not too big, right? It's just right. This takes a couple seconds longer to start up, but the video is sharp from time equals 0. And Amazon can do that because every single video in Amazon Video is 20 minutes long, 30 minutes long, 2 hours long. They know statistically people will hang out for a couple more seconds for long play videos. So they start and it's sharp from time equals 0. So that's another, this might work for you as well. We can load these in web page tests, and these are timelines. If I start with the lowest quality, 11 seconds into my load time, the video has started playing. This is the lowest quality video. If I start at the middle bit rate, it takes about 2-3 seconds longer, but this is really sharp video, and it's playing, and it looks great. So if your customers will wait 2 more seconds, we know it's sharp right away. If you start at the highest bit rate, it's trying to download the highest bit rate. It fails. This quality that took 6 seconds longer looks exactly the same as this one. So you're losing customers by doing something like that. So it's worth looking and experimenting the different ways that you're delivering video to see if it makes sense. Obviously, if you start at the highest bit rate, it's going to look great while you're sitting at your desktop on your 100 megabit per second, Wi-Fi at work. But for everybody else, it's going to be low quality and very slow. The fastest one is obviously starting at the lowest bit rate, but the quality's low. And then in the middle, you sort of have this one for longer play videos where it starts up really well, but it takes a little bit longer. Another thing that I've seen happen, here's a list of bit rates for, this is actually a TED Talk, and when I started it on 3G, it starts at this high bit rate, and then it gets stuck at the lowest quality bit rate for the entire video. And I was looking at it, and it was grainy, and it didn't look good. Now, mostly you're listening when it's a TED Talk, so that's not so bad. But I was like, why is it getting stuck there? The first bit rate is 1.4 megabits per second, like I said earlier. But if you actually look, they're streaming at 600 kilobits per second. So they're overstating it to the player. The result of this is the buffer fills up twice as fast, right? The player thinks it's going to come in at 1.4, but is loading in at 600, so it's filling up twice as fast. The video isn't going to stall, right? Because there's going to be more video in the buffer than the player actually expects. However, the quality gets maybe degraded like I saw. So what can I do? Well, what I did is I went and I rewrote the manifest file. 600, 600, 64, I just made them all match. This may stall more, but it'll be the optimal bit rate. It'll show the best quality. So there's probably a sweet spot in between those two extremes. The first thing that you notice is if you look at the y-axis, my y-axis is half the size. So I've just made all of these download faster. I run the test. It drops to the low bit rate, but eventually, this is the preview, the TED Talk intro, and then by the time the person's actually talking, it's back to 320 and almost right at 600 again. But why did it drop to the low quality to the intro? We can continue optimizing. Why is it not looking good there? Well, it turns out that if you look at the list of all the segments, it's giving me all the segments that it needs to download. This line tells me this is 5 seconds long, here's the segment, 6 seconds long, there's a segment. These intros, these are wrong. And I went through and I tried to play with it and tried to get the exact right numbers for each one of them. I couldn't make it work. It kept getting stuck and going to the low bit rate. I finally said, to heck with it, just download all 12 seconds of the intro at once at the beginning of the video. And what I found was it stays at the high bit rate and actually jumps to a higher bit rate, almost right off the bat. So again, this approach may lead to stalls in the future. The other one has no stalls but gets stuck at a really low quality, so there's a balance in between the two of them. And so it's important to find that spot that's sweet right in the middle for your application. So in conclusion, you can optimize images, deliver them faster by fixing the quality, the format, the sizing, and if you can lazy load those images, don't load the image. It's like the fastest code is the code you never run. The fastest image download is the image you never download. And for video, only download video if it's going to show up on the screen. Strip out the audio if it's silent. Resize the images for mobile. If you have a third party, whether it's video, images, or anything else, audit it to make sure it's not just downloading tons and tons of stuff. And then with streaming, if you start with the lowest bit rate, it'll start up faster. And then you can play around with the bit rate to reduce stalls, but make sure that you're not lowering the quality too much. Here are a bunch of the tools that I used: web page test, HTTP archive. These are all for images. And so with that, I'd like to thank you and let you know that images and video can be fast, but also look beautiful.